The labor market is moving online. Taxi drivers are joining Uber and Lyft. Digital freelancers are selling their services through Fiverr. Experienced software contractors are leaving contract agencies to join Gigster. Online labor marketplaces create market efficiency by improving the communications between buyers and sellers. Workers make their own hours, and their performance is judged by customers and algorithms rather than the skewed perspective of a human manager. These marketplaces for human labor are in different verticals, but they share a common problem. How do you most efficiently match supply and demand? Perfect marketplace matching is an unsolved problem. Hundreds of computer science papers have been written about the problems of stable matching, and this is a problem that often turns out to be NP complete. The stock market has been attempting to automate marketplace matching for decades, and inefficiencies are discovered every year. Today's show is about matching buyers and sellers on Thumbtack, a marketplace for local services. For the first 7 years, Thumbtack was building liquidity on its two-sided marketplace. During those years, the model for job requests was as follows. Let's say I was on Thumbtack looking for someone to paint my house. I would post a job that would say, I am looking for house painters. The workers on Thumbtack that paint houses could see my job and place a bid on it. Then I would choose from the bids and get my house painted. This was the asynchronous model. The actions of the buyer and seller were not synchronized. There was a significant delay between the time when a buyer posted a job and the time when a seller places a bid, and then another delay before the buyer selects from the sellers. Thumbtack recently moved to an instant matching model. After gathering data from the people selling services on the platform, Thumbtack is now able to avoid the asynchronous bidding process that costs people a lot of time. In the new experience, a buyer goes onto the platform, requests a house painter, and is instantly matched to someone who has a history of accepting house painting tasks that fit the parameters of the buyer. So from the user's perspective, this is a very simple, very desirable improvement. I can now just make a request and I instantly get offers from professionals who can do the request that I have been looking for. But from Thumbtack's perspective, there was actually significant architectural change that was required. In the asynchronous model, the user requests lined up in a queue, and then they were matched with pros who placed bids on the items in that queue. But in the instant matching model, a user request becomes more like a search query. The parameters of the request hit this index of pros and get a response back immediately. Xing Chen is an engineer from Thumbtack, and he joins the show to describe the re-architecture process, how Thumbtack went from an asynchronous matching system to synchronous instant matching. We also explore some of the architectural themes of Thumbtack, which we dive into in further detail in tomorrow's episode about scaling Thumbtack's infrastructure, which uses both AWS and Google Cloud. So I recommend checking out that episode as well, and it's a great complement to today's episode. On Software Engineering Daily, we've explored the software architecture and business models of these different marketplaces, from Uber to Fiverr to Instacart and now Thumbtack. And you can find all these old episodes by downloading the Software Engineering Daily app for iOS and for Android. And the great thing about these apps is that they give you all of our old episodes. In other podcast players, you're only going to find the most recent 100 episodes, but in these apps, you will find all 600 episodes with related episodes. You can find, if you listen to this episode, you might get recommended other episodes about marketplaces or about cloud services or about different architectural patterns. And we're really trying to create a new way to consume content about software engineering. These apps are open sourced at github.com/softwareengineeringdaily. So if you're looking for an open source project to get involved with, you can definitely check it out, and we would love to get your help. And with that, let's get on with this episode with Xing Chen from Thumbtack. Amazon Redshift powers the analytics of your business, and Intermix.io powers the analytics of your Redshift. Your dashboards are loading slowly, your queries are getting stuck, your business intelligence tools are choking on data. The problem could be with how you are managing your Redshift cluster. Intermix.io gives you the tools that you need to analyze your Amazon Redshift performance and improve the tool chain of everyone downstream from your data warehouse. The team at Intermix has seen so many Redshift clusters, they are confident that they can solve whatever performance issues you are having. Go to intermix.io/sedaily to get a 30-day free trial of Intermix. Intermix.io gives you performance analytics for Amazon Redshift. Intermix collects all your Redshift logs and makes it easy to figure out what's wrong so that you can take action, all in a nice, intuitive dashboard. The alternative is doing that yourself, running a bunch of scripts to get your diagnostic data and then figuring out how to visualize and manage it. What a nightmare and a waste of time. Intermix is used by Postmates, Typeform, Udemy, and other data teams who need insights into their Redshift cluster. Go to intermix.io/sedaily to try out your free 30-day trial of Intermix and get your Redshift cluster under better analytics. Thanks to Intermix for being a new sponsor of Software Engineering Daily. Xing Chen is an engineer at Thumbtack. Xing, welcome to Software Engineering Daily.
Yeah, thanks, Jeff. Great to be here.
Thumbtack is a marketplace for household labor or related tasks, event planning. Explain what Thumbtack is. Describe the marketplace and the different things that people can buy on Thumbtack.
Yeah, so Thumbtack is basically a local services marketplace where you can come and find professionals to do all sorts of work for you. And that ranges from, my last few Thumbtack hires were actually an interior designer right now to help with the house that I'm trying to close. A iPhone screen repair when I dropped my phone a couple months ago. We do things like personal training, wedding catering, tennis lessons, which I've tried before. And so it's actually quite a wide range. And, sort of the home space is just one of our big areas.
Right, definitely. Why did Thumbtack gain market share against the other competitors in this space? Because for a while there was a wide spectrum of different companies that were offering platforms to connect people who needed a wide range of services and those different service providers.
Yeah, good question. I think if I had to pin it on one thing, I think it would probably be the sort of intentfulness of the results that we return. So kind of if I think about the platforms out there, it's not that hard. I mean, it's still hard to return a good list of pros. So, certain sites can give you a bunch of profiles or kind of a list of, a directory of people to do the job. I think what made early Thumbtack really successful was we didn't just give you a list, we gave you a professional who would actually, be interested in your job and actually go to your house and paint your wall. And that, in some sense, like that end-to-end task completion is the really hard part about all of this. A little bit of my background before this, I worked at Google for a little over 5 years, and my last project there was working on Google Now, which was kind of like the first version of the Google Assistant. And with Google Now, the problem was we could never actually get the person into someone's house to do personal training or, catering your kid's birthday. Or the problem with that was sort of the product always stopped at information retrieval and, giving users a bunch of information basically on a website. But I think where Thumbtack really excels is going beyond that to sort of this last mile physical world connection, which I think is really actually the hard part.
What was Google Now? I don't remember that.
It was basically this app where we tried to predict what users would want to know before the users even knew that they needed to know that. And so, for example, we would show you things like traffic to home or flight delays or when your package arrived or news that you might be interested in or sports scores or things like that.
Oh, I actually used that when I had a Nexus. I thought it was
nice.
pretty useful.
Yeah.
So
Yep.
did it get deprecated or did it just get worked into some other
No, it's sort of
products?
just evolving into part of the assistant. There was always there was always sort of both the predictive cards and the voice search aspect of it, and the voice search sort of, and I don't really know anymore because I left a couple of years ago, but it's essentially becoming the assistant and what you see in Google Home and so on.
At this point, you've been at Thumbtack for almost 3 years. We're going to talk about the marketplace refactoring discussion, which you wrote a blog post about. It's very interesting. Basically, you migrated one form of a marketplace to a different form of a marketplace. We'll get into that, but to give people a little more background on Thumbtack, what were some of the earlier engineering challenges that you worked on in your first 2.5 years at Thumbtack?
Mm-hmm. Sure, yeah. So to give a little bit of context, the way that Thumbtack traditionally works is, I send a request for, let's say, interior design. I just did this last week. Thumbtack has a network of designers, let's say in San Francisco, and we send the request to all of the designers who we think might be interested in your job. And then the designers can then bid on the job. And, the way the business model works is they would pay to bid on the job. And I would get, up to 5 results back. So I would get, a handful of interior designers who might do my job. And that was sort of the traditional Thumbtack marketplace. And it actually worked really well because for sort of early Thumbtack, because it was fundamentally high intent when you got pros who were willing to pay to bid on your jobs, right? So if the designers are sort of, they're giving some commitment if they bid. The challenge in that marketplace is in some ways similar to the instant marketplace, but in some ways a little different in some sense. So when we get a job from a customer at Thumbtack, we need to actually try to figure out which professionals are interested. So you can think of this as basically a two-sided search problem, right? So we have a customer coming in, they are searching for pros. At the same time, we have a bunch of professionals, they are searching for customers, right? And so what we're trying to do actually is we're trying to understand what each side wants and then do the matching between them. So when I first joined Thumbtack, actually, it was pretty interesting. The matching happening in this marketplace was really simple, and I won't say how simple it was. Although it was amazing, it was kind of working despite how simple it was, and the business was growing quite fast. And one of the first things I did, so I joined the marketplace team back then, and back then the marketplace team was very small and not really doing marketplace work. We were just kind of fixing infrastructure. Once we got past, you probably know how that goes. Once we got past, getting our databases to scale and kind of building out a basic data platform, then we could start using data to try to do some of this optimization. And it was actually, Thumbtack has a fair amount of data on what local services jobs happen. So I remember one of the early things we did was we tried to use historical data to predict what jobs a professional would pay to bid on, what jobs they would send a quote on. We called this model request affinity because we were trying to measure a pro's affinity for a customer request. And we basically built this, fairly simple logistic regression based on, historical signals like if a pro historically bid on many types of jobs with many different preferences, which types did they bid on the most often? If they worked in different areas, which areas would they prefer over others based on their past data? So we had, signals like job preferences, location, and things like that in there. And I just remember when we first launched this model, we were able to decrease, for a given pro, we were able to decrease the number of the number of customer requests that we sent them by, almost like a third, while still increasing the number of bids that they sent. So that was pretty interesting. The funny backstory of the architecture of that was also, at the time it was a super early product. No one really knew whether like a model like this would matter. So instead of like building out a real data-driven system and a real serving system to serve a model, we kind of just hacked it up. So we loaded this massive file into memory in our matching service. We found the biggest machine that we could find on AWS to just store as much feature data as we could. And then I think we also had a memory leak, so we had to restart these machines weekly to make sure that that the server didn't blow up.
That's one way to solve a memory leak.
Yeah, that's one way to do it. And it's when you're trying to move fast, right, and kind of just prove if this thing works or not. And it turned out that it worked, right? So the first experiment was really successful, and we're kind of like, oh, okay, I guess we should invest in building a system to serve models.
Dice helps you accelerate your tech career. Whether you're actively looking for a job or you need insights to grow in your current role, Dice has the resources that you need. Dice's mobile app is the fastest and easiest way to get ahead. Search thousands of tech jobs, from software engineering to UI to UX to product management. Discover your worth with Dice's salary predictor based on your unique skill set. Uncover new opportunities with Dice's new career pathing tool, which can give you insights about the best types of roles to transition to and the skills that you'll need to get there. Manage your tech career and download the Dice Careers app on Android or iOS today. You can check out dice.com/SEDaily and support Software Engineering Daily. That way you can find out more about Dice and their products and their services by going to dice.com/SEDaily. Thanks to Dice for being a continued sponsor, and let's get back to this episode. Just to explain to people a little bit further who are unfamiliar with the Thumbtack marketplace, I think of this as a second generation marketplace business, whereas the first generation of general, I don't want to say home services anymore because I already said that once, it's clearly more general, but maybe we'll say real world services. You can get tennis lessons and whatnot. The first generation of these services is like you go on Craigslist or you go on some other platform that is basically an index of what you on Thumbtack call professionals, service providers. And as a customer, I'm going through these and I'm sending messages to these different people, and maybe they get back to me, maybe they don't, and it's a really frustrating experience. There's no ratings. But really, what one big thing Thumbtack solved is the problem of the customer having to do a bunch of legwork when they're just trying to spend their money. And you turn that on its head with Thumbtack, where you say, if you're a customer, you just express your interest in getting your house painted or getting dancing lessons, and you have professionals who are actually placing bids on what they are willing to accept. So the bid placing process shows their intent to actually close the deal, and it makes for a much more seamless process. And it's simple, but it's also it's nuanced. It's a different. It's almost like I think of it as, like Tinder, for example. I did a couple shows with Tinder recently, and what Tinder really did that was innovative, aside from the swiping user interface, is the double opt-in, is the fact that they only connected people and forced them to do work to talk to each other when there was a double opt-in, when both people have committed to expressing interest in one another. And it's a simple mechanism, but it lowers the friction of the overall marketplace. And when you have an insight like that, like, oh, this is actually a completely better way to do a marketplace, that's going to create a lot of volume to come in. And then that's why you're talking like, oh, the first 2.5 years there were like, okay, we figured out this breakthrough in how to do the marketplace right. Now let's just build the infrastructure to be stable and sort of have like the minimum amount of work, of infrastructure that will actually service this breakthrough in marketplace dynamics. Am I describing things correctly?
Mm-hmm. Yeah, definitely. That's exactly how we think about it.
Yeah. So beyond that, once you had the infrastructure stabilized, you were able to say, okay, now that we've got this infrastructure stabilized, let's figure out how can we improve this marketplace. So in the original model, again, the pros are bidding for jobs. So if I'm a professional painter, I'm going to need to put in the time and the effort and the money just to get hired. And then if I win the bid, I have to go and complete that paint job. What are the pros and cons of that marketplace format?
Yeah, great question. So, probably the strongest pro to that format is the intent of the bid that you get. And so, to your point about first versus second generation local service marketplaces, in the first generation marketplace, you're really just getting an index of I think of it as sort of this flat index of contact information, right? And you get a little metadata and a bunch of contact information. Thumbtack, in some sense, is looking to, in the second generation of local services, we're trying to kind of go beyond that flat contact info to actually send the person to your house to actually do a job. And so that's the biggest benefit of the bidding model. The biggest downside of the bidding model, and if you think about what a professional is doing, and we dog food our products here, and so you sign up as a professional, let's say a professional resume writer, and we've helped write some resumes here, and what happens is you find that you're actually doing the same job selection over and over and over. And so, like, let's say I can help write tech resumes in the Bay Area. Every day, if I'm really doing this as my living, every day I'm kind of clicking like, all right, here's a tech job, 3 years of experience in Oakland. Here's another tech job, 3 years of experience in San Francisco, bid. And you're kind of just doing this like N times a day over and over. And it's kind of like, well, that's a lot of effort, and it does not really lend itself to scale. And that's probably the biggest downside.
Do you have any numbers that illustrate how much volume is going through the system, just to give people a perspective for how much volume is going through the marketplace?
Yeah, so I mean, roughly speaking, we do millions of jobs, millions of projects on the platform every year. We have 250,000 active paying pros. And, to give you some sense here, when we say millions of projects, each project is a pretty significant thing, right? Like a wedding catering job, an interior design job, personal training client. So these are big projects, and we're doing millions of them.
How much internal tooling do you have to build in order to support the users in the marketplace? Because I've dealt with all kinds of these marketplaces. I've dealt with Uber and Fiverr and Lyft and all these different things. They all have internal support tools because we're still figuring out how online marketplaces will collide with the real world. And there's a lot of frictions, and so you have to give the customer success team the tools to deal with those edge cases. What kinds of internal tooling do you have to build to support those users in the marketplace?
Yeah, good question. So we are actually somewhat different from a business like Uber or Lyft, where for them to really scale the marketplace, they kind of go more city by city, and there's an ops team on the ground to kind of build up the inventory in that city. For us, it's actually much easier. So there's not a strong sort of ops-driven component to our scale, and the basic advantage of Thumbtack is we can kind of just turn it on anywhere, and anyone who is an existing small business in that marketplace in that market can just go ahead and use the platform. And so that's in some sense like the inherent advantage of the way the platform works is we don't really require like a strong ops component to scale. Now that said, we do definitely have a great ops team here that helps with very specific things. So one very specific area is marketplace trust and safety, and this is where we have a great sort of, I would call it, human computer interface in the team sense, where on the human side we have a team reviewing cases, but then we also try to automatically detect issues on the computer side. So to give one example of this, when I got here, most of our requests were actually passed through an ops team to scan for scams, because customers will actually try to scam pros. And a lot of these are like classic, like, I bought a house and, can you wire an extra amount of money to my landlord who's in, the UK or something. And so it's sort of these like classic like wire fraud scams, and people would try to scam the pros with this. And so initially when Thumbtack was small, we just said, okay, we'll just send all of these to a human to read, right? It's kind of the simple bootstrap solution. As we got bigger and bigger, obviously that created scale problems and bigger delays. And so actually just this past year, we started deploying machine learning systems to basically, automatically pick out which requests are likely to be spam. And we use all sorts of signals around the customer requests and where it's coming from and the content of the request and third parties to sort of add signals. And so, that gives you a prediction of whether this thing is a piece of spam or not. And then given that prediction, we can decide if we want to automatically deal with it or send it for manual review, and sort of, just building out these interfaces between our automatic systems and the manual review is really important.
Now that we've given people a table stakes view of what Thumbtack is and how that unique marketplace component works, let's describe the reformatting of the marketplace, because that will get us towards a discussion around software engineering, because you had to actually reformat the backend infrastructure in order to accommodate this marketplace change. So we talked about baseline transaction that Thumbtack started out as, where I, as a user, post, hey, I'm looking for a painter to come paint my house, and you, as a professional painter, are going to see that request, and you can choose, okay, I want to bid on this. I want to state a price and when I'm going to do it, or the details of what I'm going to offer to you as the customer, and the customer can accept that. Describe the new marketplace structure that you decided to move to.
Yeah, so to give some context on this, what we realized, so, we were talking about kind of first versus second generation marketplaces. And, what we realized is in this bidding world, it's great that we get high intent pros, but you only get so many of them because you're forcing them to sit there and kind of, click these buttons in our app 10 times a day. And they're clicking like the same buttons, right? And it's sort of like, well, that's what computers were invented for. And so we kind of realized this, and we're like, oh, well, actually, you don't need them to click the same buttons 10 times a day. You can just have them click the buttons once and tell you that, they are an interior designer with contemporary modern tastes, and they like to do, design of rustic condos in the Mission in San Francisco or something. And they don't have to pick that every day. They can just tell us once. And then you can also say, okay, well, what if they also tell us their schedule? What if they also tell us when they do these jobs? What if they tell us their capacity, how many jobs they're willing to do, and so on? And so if you collect all of that information from a pro, what you are really creating is sort of, I would call it this, to your terminology, this second generation index. This time we're not indexing pros, we're not indexing a bunch of contact information and profiles. What we're indexing is actually, in some sense, future jobs that could be done, right? We're indexing the fact that, in San Francisco on Saturday nights, there are 4 DJs that play EDM, and these are the types of venues where they are willing to play, and these are the types of music that they like. And by the way, here are some past jobs. And if we actually know that, like, in the future, there are a bunch of, these DJ jobs that are going to happen, if we have a customer who's like, well, I have a, birthday that I want to get a DJ for. I don't know who does that, but, let's say someone's like, I want a DJ for my birthday. We can say like, oh yeah, here are 3 people who do, the DJ job, that the kind of music that you want on the day that you want it. And, and if we do that right, then those 3 people will actually be willing to show up at the venue and DJ the job, right? And so in some sense, we're trying to create this local services jobs index of sort of future jobs that can happen. Does that make sense?
It does. Well, and the part of this that becomes problematic is indexing these different pros is not as easy as it sounds. It's not a highly normalized set of data. So you have this thing that you describe as the laundry problem, which is that you can't just categorize all of the house cleaner. So if I want a house cleaner, there's a question of, is the house cleaner that I'm going to order on Thumbtack going to do my laundry or not? Some of them are willing to do the laundry. Some of them are only willing to just do the house cleaning, because you could argue, okay, doing laundry, that's not cleaning the house, that's doing the laundry. And so certain pros that you would assume are a good fit to do a task are actually maybe not going to do that task well. So for example, another example, you have IKEA builders who don't like to pick up the furniture. They just like to come by your house and build the furniture. But some of them are going to be willing to pick up the furniture. Some math tutors are going to dislike tutoring a student in calculus. They're a math tutor, you would assume they're going to do calculus, but that's actually not necessarily the case. Why is this so problematic? Why is the laundry problem so problematic when you're trying to build this instant matching marketplace?
Yeah, so it gets really interesting when you start to see a significant amount of both the supply and the demand side of a market. So the sort of the examples you called out where you kind of realize pros have very specific preferences about the kinds of jobs they want to do. And so for us, what we're trying to do now is, we want to create this index of pros of local services jobs. And when we get a customer, we want to be able to tell them, okay, here are the professionals, the prices, and the times that your job could happen. Now, the interesting thing becomes these two things don't always line up, right? So it's a two-sided search. The professionals are searching, the customers that the professionals are searching for are not always the same customers that show up in a marketplace. And so this thing that we call the laundry problem, we sort of jokingly branded it that because it was kind of funny when we found out that like house cleaners don't like to do laundry, at least in the San Francisco Bay Area. And so there are actually a few different aspects of this problem. So kind of the first, so this kind of goes into the core, some of the core matching challenges here at Thumbtack. So one of the first problems in this area is you can think of this as, in kind of machine learning speak, it's sort of this classic explore versus exploit problem. So if you know that you have a great professional who can do house cleaning, laundry, whatever you want, or you have a great math tutor that can just do everything up to like college level, whatever, linear algebra, you could give them as the top result for everyone. You could sort of try to send them to everyone's house to do all of the jobs. Now, the problem is going to be they won't have the capacity to do all of the jobs. And also, another professional that might actually be really good at laundry or calculus will never realize that because we'll never send them to do these kinds of jobs. And so when you do the matching, it's actually really important not to sort of naively optimize a black box, right? So earlier I talked about this request affinity model where we optimize for the probability that a pro will quote on a job. If you just naively followed that optimization and you just kind of said, okay, I'm going to order the pros this way, I'll take the top 10% of pros, and I'll just return that set for every job, you'll actually get a nice bump in metrics probably in the short term. But in the medium to long term, I could almost guarantee you the metrics would go south because what will happen is you'll effectively reduce your supply, right? And so that's kind of the challenge of balancing how much do you kind of exploit the best pros who can do all of these sorts of jobs in the market versus explore pros who can't do all of these jobs.
All right. To pull these different threads together, let me see if I understand this correctly. So the original model is essentially asynchronous. I, as a customer, publish that I'm looking for a house painter, and I have to wait while the different pros bid on that job. So there's a little bit of waiting. There's some asynchronicity. The place that you wanted to move to is I, as a customer, state that I'm looking for a painter, and I am instantly matched with people who have, in the past, shown to have a propensity to accept jobs that are similar to mine. And they have a certain bid that they have made in the past on these types of jobs, and so I automatically get matched with a person with that bid. And that is a synchronous process. I make a request and I instantly get a response. Am I architecting things correctly so we can get into the engineering?
Yeah, exactly. So from a customer perspective, we can now give results instantly because we've already asked the pros upfront what they are, what types of jobs they are willing to do. And the other thing I'll say is on the pro side, this also becomes a fundamentally higher scale supply because now they're no longer gated by the fact that they have to quote on every single request.
Do you have a product that is sold to software engineers? Are you looking to hire software engineers? Become a sponsor of Software Engineering Daily and support the show while getting your company into the ears of 24,000 developers around the world. Developers listen to Software Engineering Daily to find out about the latest strategies and tools for building software. Send me an email to find out more. Jeff@softwareengineeringdaily.com. The sponsors of Software Engineering Daily make this show possible, and I have enjoyed advertising for some of the brands that I personally love using in my software projects. If you're curious about becoming a sponsor, send me an email, or email your marketing director and tell them that they should send me an email. Jeff@softwareengineeringdaily.com. Thanks as always for listening and supporting the show, and let's get on with the show. So the original infrastructure that reflects this is customers are making requests. They're posting jobs for painting or house cleaning or whatever else. And those jobs are getting queued up in SQS, a Amazon simple queue service. And then those requests get pulled off of the queue, and you have these workers that are matching those requests to pros, and you're notifying the pros, hey, new jobs have been posted. Maybe you want to bid on these new jobs. Very simple, scalable system, but it has that asynchronicity where you have the jobs that are being posted to the SQS, and then asynchronously these workers are CPU workers are pulling jobs off of the SQS thing and matching them with pros who might be interested in those jobs. That is an inherently asynchronous architecture, and you wanted to go to a synchronous architecture. Why didn't that original architecture suit your needs?
Yeah, so the asynchronous architecture was basically designed for flexibility in terms of letting us do whatever we wanted with our matching. So what I mean by that is, let's say we wanted to compute various regression models. Let's say we wanted to pull from various online sources of data and hit a bunch of backends to get additional data to sort of enrich the data before pro selection and ranking. It gave us flexibility to do all of that very, very slowly, which is obviously not good, but in this case didn't matter because it was an asynchronous user experience. And so just having the flexibility to do it slowly actually meant that we could focus our engineering effort on the hard part, which was sort of the matching algorithm and modeling, instead of trying to compute it really fast. It actually gave us a lot of room there. Now, obviously, when you need to return results instantly to a customer, it looks a little bit different. It looks a little more like a search where a customer is directly searching over an index of jobs, right? And so now so what happened was we sort of said, okay, well, we want to build up this index of jobs and return results instantly. That actually basically required us to change the whole backend, right? Because like an asynchronous worker architecture looks very different from a synchronous search stack. And so actually the first thing we did in sort of the spirit of moving fast and scrappy as a startup, the first thing we did was we decided we would run a test without changing the architecture, where we sort of just like wired up the results coming through these SQS queues and wired them back to the website and had sort of the front end clients polling, and you had this awful like 10-second 95th percentile latency, which I'm sort of even embarrassed to say here. But we ran like a small test this way because it was super fast. We were able to get it out within weeks. It sort of proved that instant results are better than slow custom results.
So you hacked the infrastructure to build a minimum viable product of the new instant matching service, but the backend was not exactly where you needed it to be yet. You just used this slightly modified infrastructure to validate that this was something that people were even going to want. And you moved to this instant matching service, which required a new backend. And so this new instant matching service, what was required in the re-architecture to actually make those modifications to fulfill the new requirements for the synchronous matching service?
Mm-hmm. Yeah, so effectively we switched to essentially what looks like a modern search stack. So it's backed by Elasticsearch, and we put some of the core jobs index information into Elasticsearch. We removed, the SQs and things like that, and now we have our matching service querying Elasticsearch. So there's sort of, you can think of the search process in sort of three steps. So there's retrieval, where we do sort of the basic filtering by location, by job type, and then we enrich that data with further calls to other backends. For example, we might call the quoting service backend to get prices for that job. And then finally we do ranking. And so once we have kind of all of these price jobs, we again look at sort of these two sides of the search problem. So which professionals are going to be responsive and actually go out to the person's home and do the painting job, and which professionals are going to be most interesting and relevant to the customer, and sort of balancing these two sides of the search.
In the asynchronous model, as you mentioned, you had not infinite time, but you had much more time to process and do the matching properly, to get the right pros presented with the right jobs and do the matching more effectively. In this situation, it's much more latency sensitive. So what was the offline, the things that you could essentially put in the request, the loop in the asynchronous process when the user posts their job, I want to get my house painted, and you can do all kinds of processing around that request to be like, okay, how let's figure out who are the best pros that we can recommend for this job, and you've got plenty of time to do that. How does that change when you have to move to this synchronous model and you've got to, I guess, do all that stuff offline before the requests actually come in?
Yeah, there are a couple of big things that we had to add to make this work well. One of the big ones was setting up this streaming near real-time updater system for our Elasticsearch cluster. And so imagine professionals are changing their preferences all the time. When they change their preference, you don't want to serve a customer a job from that professional where their preference is outdated. Someone says, I don't do Italian cooking anymore. I'm moving on to modern American. And then 2 hours later, you serve them in a search result for Italian. That looks really bad, right? And so you can't do that. And so what happens is you have to basically take all of these changes coming from product front ends and then essentially aggregate them through this indexing pipeline, this real-time indexing pipeline, and then update the Elasticsearch index in near real time. And that was challenging to get right? Because you have to do a fairly high volume of writes to the index. If you have some writes that fail, you also want to have some sort of backup job. So we actually have essentially a backup job that runs every night to sort of validate the consistency of the index against our other databases. And even the way that you roll this out was pretty tricky. So we actually spent a lot of effort. There were sort of two ways where we spent a lot of effort. We spent a lot of effort validating that the numbers and the results were correct, right? Because you're actually switching essentially the core index that Thumbtack runs on from one set of tables to another. And what we did was we launched both side by side, and we would look at the diff in the numbers. And anytime the diff didn't match, we would ping our engineers and say hey, the diff didn't match, and kind of give a bunch of debug logs, and we'd look into that. And we got to the point where we were looking at, diffs
So
of
you diffed two requests, just two requests to the same service, the same system.
We diffed for one customer request. We ran it through both the old slow index and we ran it through the new fast index.
Yes.
And the purpose of that was to make sure that the index is matched, because you had this, real-time updater system that could potentially drop an update every now and then. Or maybe there's some replication lag in, between clusters. And so actually what ended up happening is you get down to it, and we actually found a bunch of bugs in the old system because we get these diffs and we're like, this doesn't make any sense. And we got down to the point where we were finding differences of 5 pros out of, hundreds of thousands of candidates. Right. And sort of these 5 pros are slightly different in this set versus that set. How did that happen? And actually, when we dug in, we actually found a couple of, latent bugs in the old system that, it's actually kind of hard to find if you don't have a comparison like this.
Did you have a different data store before you moved everything into Elasticsearch for the purpose of this new matching service?
Yeah, so one of the primary data stores that we used was DynamoDB, and we had essentially created a bunch of kind of one-off indexes using just simple key value stores. So for example, our geo index was using this concept of S2 cells, which is it's a Google thing where you divide the Earth into this grid, and you can map from this grid to a list of pros. And so basically, we had a bunch of these indexes there, but it was actually quite slow. So doing kind of a series of DynamoDB queries to a bunch of these one-off indexes was actually pretty slow compared to Elasticsearch.
Can you tell me some of the challenges of running a big Elasticsearch cluster? Or I guess first migrating everything to an Elasticsearch cluster?
Yeah, I think one of the big challenges we had was basically some of the writes would just fail because we were trying to, especially our batch jobs overnight, we're just trying to write so much data. So, a pro can have lots of services. For each service, they might have lots of preferences. Let's say they have specific zip codes they want to work in. Well, New York City metro area has thousands of zip codes, and then multiply that by hundreds of services that a pro could offer, multiply that by, many, many pros, and you sort of get the idea. And so the volume of updates was actually quite large. And so we actually worked very closely with our SRE team to basically tune our clusters so that we could handle all of those writes.
And what do you have to do to tune an Elasticsearch cluster to handle lots of writes?
I mean, it's basically the composition of the machines and the way that you do the writes. And so we use Spark as our offline, data aggregation framework. And so Spark, if folks don't know, Spark is basically a MapReduce framework, and it's written in Scala. And so we use Scala and Spark to kind of do these aggregations. And so, effectively it becomes a bunch of MapReduces, right? And so you're basically doing a bunch of parallel writes into your cluster. And so at some point, it's actually very easy to write a Spark job that blows up the cluster, right? So for example, we would do things we'd add client-side throttling on the Spark jobs and just change the way that we were actually doing the MapReduces to put less load on the cluster.
So if I understand correctly, you've got a bunch of writes that are coming in that are updates to the pros, like new pros, their preferences are changing, they're updating their profiles and whatnot, and you use Spark as an in-memory working set where you're just throwing these writes into it and batching them up, and then you're writing these batches to the Elasticsearch cluster out of the Spark cluster. Do I have it right?
Yeah, so to be a little more specific, so the online real-time system actually takes updates from product front ends, puts the updates in a bunch of queues, and then there's a streaming service that reads from the queues, decides what it needs to refresh, and then reloads that data into Elasticsearch. Mm-hmm. The scale of that side is actually easier to deal with in some sense because we're not doing these massive batch writes. That tends to be more of a steady stream of stuff. What we also have is sort of this backup job because and especially early on in this system, the system is all of our revenue is flowing through the system, right? So it can't break. And so we need redundancy. And so, what we did was we also wrote a batch job that would basically take the data from the product services and use Spark to batch write that into Elasticsearch, and we would run that every night, and that kind of guaranteed that any discrepancies that happen, any hiccups in the real-time streaming system that happen during the day would not just like build up over time, right? Imagine you get a handful of timeouts on Elasticsearch every day, and you never do anything about this. Like over time, you could actually have a fairly corrupted index of matching data, and so we didn't want this to happen, especially when while the system was early. We didn't have a lot of guarantees on the streaming side, and so we had this backup MapReduce run every night where we would basically take a snapshot of the data and put that into the index and do a diff. And and that batch job was actually pretty big, and that's the one that was challenging to get working well.
So you mentioned you work with the site reliability engineering team to figure out how to get this Elasticsearch cluster tuned properly. Can you talk a little bit more? And I know we're running out of time. It's totally fine, but talk a little bit more about how SRE works at Thumbtack, because this is a service that people are. It's a service where your uptime is super important. The reliability of the service is super important because people are making their living off of this service, and people are making expectations about the work that they can get off of this service. So how do you look at SRE, and maybe if you have an anecdote that illustrates the SRE team?
Sure. Yeah. I mean, our SRE team is amazing, and I'm not just saying that to get stuff from them, but they are actually amazing. I would say they're incredibly scrappy, and they sort of create the foundation of the infrastructure that all of the teams use, all of the product and systems teams use to build out the product effectively. And so, for example, in this case, they really paired with us very closely to doing the Elasticsearch cluster and worked with our engineers to get the cluster working well. But I mean, I think the high level thing is, and this kind of reflects the culture here at Thumbtack, is just we try to be very collaborative across teams. And so it's, we're not like companies where there's sort of this throw it over the wall culture with SRE, where it's like, oh, SRE has to do this, let me like send them a ticket and wait. Here it's sort of like we sit basically right next to each other and we just work all the time. Like right now we're working on capacity and load testing for some of our systems, and we kind of just sit together and work on it really closely.
Well, let's wrap up. What have been the results from this migration from one form of your marketplace to the new form?
Yeah, it's actually been really exciting. So, one thing I mentioned earlier was the old model is sort of inherently supply constrained because you're waiting for people to kind of sit there and click buttons and bid on things. The new model is inherently higher scale because we are doing the indexing work up front, and so we can return as many results as we have capacity for. And so there's two data points that really illustrate that. The one data point is a measure of what percentage of requests do we return at least 3 quotes on, like 3 good quotes where the professional is responsive and is willing to go to your house. And so we have this metric, and essentially the metric has grown over 2x in the markets where we have started to add instant match. And it continues, and if you just look at the graphs, it's just like widely diverging, and the instant match market just continues to grow, which is pretty exciting. The other metric that's interesting is, Thumbtack has, because of this bidding model, Thumbtack has historically been supply constrained, right? Because we're looking for really high quality, high intent pros, and it's hard to get a lot of them. Actually, in the new model, what's happening is pros are giving us a capacity of how many jobs they're willing to do. So they're actually giving us a budget that they're willing to spend every week. And it turns out that we are now no longer able to spend the vast majority of those budgets. And so for pros and instant match, I think when I wrote the blog post in August, we were probably only spending about 25% of pros budgets. We were only using up 25% of our pros capacity. That number continues to drop, and I believe, yesterday I just looked and it's something like 12% now, where like in these markets we're starting to look demand constrained, which is a great problem to have because we can go out and find more customers too. There's lots of other ways to improve our matching to use the capacity that we have, and so that's also a pretty exciting data point.
All right, well, Xing, it's been great talking to you. This is a really fascinating top-down discussion, and it's highlighted more in this blog post that you made. We didn't get to nearly everything that you covered in the blog post, but I'll put that in the show notes. You've got some great diagrams that help to explain some of the things that may have been easier to understand visually than over audio. But thanks for coming on the show. It's been great talking to you.
Yeah, thanks, Jeff. It was great chatting with you.
Simplify continuous delivery with GoCD, the on-premise, open-source, continuous delivery tool by ThoughtWorks. With GoCD, you can easily model complex deployment workflows using pipelines and visualize them end-to-end with the value stream map. You get complete visibility into and control over your company's deployments. At gocd.org/sedaily, find out how to bring continuous delivery to your teams. Say goodbye to deployment panic and hello to consistent, predictable deliveries. Visit gocd.org/sedaily to learn more about GoCD. Commercial support and enterprise add-ons, including disaster recovery, are available. Thanks to GoCD for being a continued sponsor of Software Engineering Daily.
Wow!